Welcome to Tech Teach.
So next, we will be looking it out. What are the different performance parameters that will be defining a processor? So if a processor is there, how its performance parameters are defined, we will be going through that. So performance parameters of a processor. So there are multiple parameters that will be defining the processor performance. So for that, we will be going through one by one. So first one is like the clock speed. So clock speed, if the clock speed is higher, the processor is considered to be like it is going to operate at faster speed, basically measured in gigahertz. So this clock speed is basically measured in gigahertz. Nowadays we are having the processor that have like 2.6 gigahertz speed, 1.5, likewise 3.5 gigahertz speed. This indicates how many cycles per second CPU can execute. So per second, how many cycles a CPU can execute. So higher clock speed generally means faster processing. So higher is the clock speed generally means the faster is the processing. So how many cycles it will be performing in 1 second, that is given by the clock speed. So in 1 second it can have more number of cycles. So it means it can execute more number of instructions per second. The next one is the core count. So this core count is basically the counting of the number of processors. Core in the sense the processors. So modern CPUs have multiple cores, allowing them to handle more tasks simultaneously. So more cores can improve multitasking and parallel processing. If more cores are there, means number of processors are large. The processor count is high. So if the processor count is high, the system will become like a multi-core system. So if a multi-core system is there, it will be performing a particular task in less time, and also it will be able to perform multiple operations, multiple applications. It will be running at the same time. So it is a multitasking type of system, and it also supports a parallel processing. Parallel processing in the sense it will be doing similar tasks or two tasks at the same time. Okay, that is the parallel processing because it has multi-core system. So it will be supporting multitasking and parallel processing type of operations. Next one is instructions per clock. So it is called like IPC. So this measures how many instructions a CPU can execute per clock cycle. So how many instructions can be executed by the CPU in one cycle is basically the instructions per clock. So higher the instructions per clock can lead to better performance even at lower clock speed. If the clock speed is low, but that CPU can execute more number of instructions per clock, so its performance will be better. The next performance parameter is the cache size. So with processors, there are the cache memories that are basically attached to the processors that are inside the processor. There are different types of different levels of cache memory. So there is a L1 cache, L2 cache, L3 cache. So different levels of cache is there into the processor. So generally the L1 and L2 cache is basically considered to be inside this processor or inside the core. And this L3 cache is between different cores. This cache size is basically going to further increase the speed as well as the performance of the processor. It's like the cache memory is basically facilitates the storage of frequently accessed data by the processor into the cache memory. So whenever the processor wants to access a frequently accessed data, it will be available near to the processor, so it takes less time. So cache memory facilitates the faster access of the data, so it will be reducing the time and increasing the efficiency of the processor basically. So the CPU cache stores frequently accessed data to speed up processing. It speed up the processing. So larger cache can reduce the time needed to access the data from the main memory. So instead of going to main memory, that is RAM, for retrieving the data by the processor. Processor will be able to get the data directly from the cache memory available inside the processor. So that facilitates shorter time to access the data. So it will be increasing the performance of the processor. Next one is thermal design power. So thermal design power, you can consider it as the one that basically indicates the maximum amount of heat a CPU can generate under maximum load. So the thermal design power is like if a CPU is working at its maximum load, what maximum power or what maximum power dissipation will be done in the form of heat, that will be given by the thermal design power. So lower TDP value can mean more efficient processor. If a processor is having lower TDP value, thermal design power value, it's meaning even if the processor is working at its maximum load capacity, then also it will be generating low power dissipation it will be doing, or it will be generating lower heat. So that system or that processor will be considered to be a more efficient processor. Next one is the sixth one, that is the execution time. So the total time taken to complete a task is basically called the execution time. So execution time, in the sense, this can be influenced by the clock speed, IPC, and other factors. So execution time of an instruction can be uh, considered to be based depending on the clock speed. If the clock speed is high, that means it will be taking low execution time of an instruction. If the IPC, that is instruction per clock, is high, then also the execution time will be less. So either the clock speed should be high, so the execution time will be reduced, or IPC, that is instructions per clock, is if high it is, then execution time will be lower. So execution time taken should be lower by the processor so that it can be having more efficiency, or performance will be high, or speed will be high. Throughput is another parameter that basically defines the performance of the computer systems. So here the number of tasks a CPU can complete in a given time period is basically considered as the throughput. So in a given period of time, how many tasks are completed by the CPU is considered to be the throughput. So higher the throughput indicates better performance for multi-threaded applications. So if a CPU is performing multiple operations, and it is performing multiple operations, in the sense it is performing multiple tasks, multiple instructions it is executing, and that multiple tasks, that is, it is completing in per unit time is high, then we will be calling like it is having a higher throughput. So if a system is having higher throughput, if a CPU is having higher throughput, it is considered to be having a better performance. The last parameter is basically the latency. The latency is the delay before a transfer of data begins following an instruction. So like an instruction is there, if an instruction is being executed, instruction 1 is there. After the instruction 1, suppose there are an instruction 2 is there. So if instruction 1 is completed and instruction 2 needs to be starting, so between 1 and 2, end of the 1 and start of the 2, between these two, what is the gap is basically the latency. You can think of in that sense. So what is the delay before a transfer of data begins following an instruction? So if one task is being completed, after completing the task 1, and it is going to start the task 2, so between the end of the task 1 and start of the task 2, there is a time gap. So this time gap is basically called the latency. So lower the latency can improve the responsiveness of the CPU. So if this gap between end of the task 1 and start of the task 2, if there is a gap, if this gap is lower, then we can say the CPU is more responsive. Or we can say like it is having low latency. So between end of a task and start of a task, if there is a no gap, there is no latency. If there is a gap, that is called a latency. I hope you have got the basic idea.